today we're going to talk about our group presentation for topic 2. First of all, I will introduce to you our group members. First one is Muhammad Ahmed Zkour, second one is Ahmed Khalid, third one is Hamad Murshid, and the fourth one is Ali Mheri.
BC 2.5 Observation: a set of data derived from an object. Experimental unit: an observation. Each object measured according to its various aspects such as temperature, concentration of constituents of some constituents, frequency of occurrence of some phenomenon. Each of these aspects is denoted as a variable or feature. BC 2.6 Qualitative or categorical data have no logical order and cannot be translated into a numerical value. Eye color is an example because brown is not higher or lower than blue. Quantitative or numerical data are numbers and that way they impose an order. Example are age, height, or weight.
BC 2.7 Define numerical data as the data that has a sense of measurement involved in it, and it is often referred to as quantitative data in statistics, and give example on it. First one is a numerical data is information that is something that is measurable. It is always collected in number form, although there are other types of data that can appear in number form. It's also called quantitative data in statistics. Numerical data examples, which are usually expressed in numbers, includes census data, temperature and age, and mark grading, and annual income, and time, and height. Two examples from real life. Temperature. The temperature of a given body or place is measured using numerical data. The body temperature of a body given to be 37 degrees Celsius. The second example is time. The amount of time it took a runner to run a race, for instance, is a numerical data. It doesn't matter whether it is being measured in hours or seconds or minutes. It always takes a numeric value. BC 2.8 Differentiate between the two types of numerical data, including discrete and continuous data types, and give example on each. That discrete data involves around concrete numbers that are determined by counting. 2. Discrete is countable variables. 3. Examples. The first example is the number of customers who bought different items. Second example, the number of customers in each department. Continuous data involves complex numbers that are measured across a specific time interval. Continuous data is measurable variables. Third examples. The first example is the weight of newborn babies. The second one, the daily wind speed. BC 2.8 Example of discrete versus continuous. Discrete, for example, the graph as shown about height and age, and the second one, continuous, as shown the graph volume and time, how it is graph plot.
The four scales of measurement are nominal, ordinal, interval, and ratio. Nominal is categorical data and numbers that are simply used as identifiers or names that represent a nominal scale of measurement. Ordinal data is a statistical type of quantitative data in which variables exist in naturally occurring ordered categories. Interval data, also called an integer is defined as a data type which is measured along a scale, in which each point is placed at equal distance from each one another. Ratio data is defined as quantitative data having the same properties as interval data, with an equal and definitive ratio between each data and absolute zero being treated as a point of origin. Examples of nominal data include country, gender, race, hair. Examples of ordinal data include socio-economic status, education level, income level, certification rating. Examples of interval data: the difference between 100 degrees Fahrenheit and 90 degrees Fahrenheit is the same as 60 degrees Fahrenheit and 70 degrees Fahrenheit. Examples of ratio data is the measurement of height. Heights could be measured in centimeters, meters, inches, or feet. It's not possible to have a negative height.
Pandas. In pandas, we determine number of unique values, identifying the data type as well as percentage of missing values for each variable. Matplotlib is a comprehensive library for creating statics, animated and interactive visualization in Python. SciPy is scientific computation library that uses NumPy underneath. SciPy stands for Scientific Python. It provides more utility functions for optimization, stats, and signal processing. NumPy is Python library used for working with arrays. It also has functions for working in domains of linear algebra.